Welcome to BKSS Academy. I hope you are in fine state of health and mind. Now we are discussing about traveling salesman problem by exhaustive search. For going to the topic, first we will discuss about some examples. Suppose a newspaper boy will give the newspaper at different houses. So he will find out in which way I will go so that I will cover the short distance and I will reach at every house to throw the newspaper. Similarly, a salesman when trying to sell his product in different cities, he will also find out the shortest path among the number of possible paths. Then among the number of paths, he will select the shortest path. One example is here. Suppose A, B, C are the three cities. So salesman will start from here. It will go to B. It will go to C. Then it will return back to its starting place. Similarly, it can go by this way also, A to C, C to B, B to A. So these are the possible ways and possibility which will be minimum that he will select. As per the exhaustive search principle is telling, there will be constraint. So those constraints are telling that visiting all the cities exactly once. It will visit all the cities exactly once. After selling the product, the salesman will return to the same place where he had started his expedition. From A, it is starting his expedition A to B, B to C, and he will return to its starting position C to A. This is the constant. It is nothing but finding the shortest path in Hamiltonian circuit of a weighted graph. So what is Hamiltonian circuit? When we are going from A to B to C and reach and again return to A, this will be the Hamiltonian circuit. It is the circuit which is having n plus 1 vertices. Suppose this is 3 vertices, but each have to cover 4 vertices. 1, 2, 3. When it will return again, this will be 4. So 3 plus 1. Similarly, it becomes n plus 1. Example is, suppose vertices are V0, V1, V2, V3, V4 up to Vn. After covering all the vertices, again it has to return to the V0 where it has started. This is the V0. V0, V1, V2, V3 up to Vn, then V0. N plus 1 vertices, as I had told you, where first and last vertices are the same, that is called as Hamiltonian circuit. One example is there. Suppose these are the cities A, B, C, D, and this is the distance we have to cover from A to B, B to C. This much distance it is covering. So the salesman will think in which way I will start from A, go through all the nodes and reach at A will be the minimum cost. So we have to find out all the possible ways first, then we will compare, then which will be the minimum that we will select. So first A to B, B to C, C to D, D to A to B 2, B to C 8, C to D 1, 2, 8, 1, 11, D to A 9. So 20, this is 20. Similarly, A to B, B to D, D to C, C to A. This will be 10. Similarly, A to D, D to C, C to B, B to A. This will be 20. These are the possible paths or possible routes. From the result, we will compare which is minimum. So these two are the minimum things, minimum cost bearing paths. So these two will be our optimum path. Then salesman will think which one he will take. this A, C, D, B, A or A, B, D, C, A. From this, salesman has the responsibility to choose it, whether the second one or last one. Generate all possible routes. Optimum route will be second and sixth. I had told you this is the second, this is the sixth. So salesman will select either of one. Time complexity will be, suppose n nodes or n cities, possible route will be n minus 1 factorial, because this is 4 nodes, 4 minus 1 factorial, this is 3 minus 1, it is 6, this is 1, 2, 3, 4, 5 and 6, 6 roots are there, 6 roots are there. So this is the calculation. Suppose n nodes are there in a graph, then possible roots will be n minus 1 factorial. This is the permutation of n minus 1. So time complexity will be big O of n minus 1 factorial. That is the time complexity of the traveling salesman problem of by exhaustive search. Thank you and take care.